All right, guys, last step. So now, in order to figure out our initial question, just to remind you guys, we were trying to figure out, is non-webbing, is this trait becoming more common in the population versus webbing? So in order to do that, we had to know what our initial population looked like. What was the frequency of the dominant allele, or P, versus the frequency of the recessive allele, Q. And then we can go out a few generations later, take the exact same information, but it would be one step shorter this time, I promise, and then see if our population is changing. Is that trait becoming more common? All right, so let's say we went out a few generations later, and now our current population size is 200 iguanas. So I don't know, maybe it's like 20 years later or something like that, because iguanas can live for a pretty long time. So even though we have a population drop, that doesn't mean that there might be changes occurring in our population. So we still need to continue on, to figure out this answer. And so to figure out, we need to know our total, again, number of alleles now for the trait. How many dominant and recessive alleles combined do we have in this population of 200 iguanas? So again, individuals have 2 copies of that trait, so 200 times 2. Now, there are 400 alleles in our little gene pool for this trait versus our initial 1,000. Again, that doesn't mean anything. We still want to go ahead and continue on our calculation. All right, so let's say we went out with our geneticist and we were able to count how many individuals were homozygous dominant. Let's say now that there are 50. Let's say we went out and we figured out how many heterozygotes do we have. Say there are now 25. And then homozygous recessive, let's say there are 125. So again, these guys are non-webbed, and these guys have webbed feet. This marker is kind of running out. Oopsies. So the first thing we can do, actually, we can actually skip a step we did in our previous example to get to it a little bit faster, is now let's calculate the frequency of our dominant allele in our population. Again, there are 2 different ways to have at least one of those dominant alleles, either your homozygous dominant and then heterozygous. So we had 50 individuals that were homozygous dominant. To be that, they have to have 2 copies of that same dominant allele. So 50 times 2. So there we have 100 alleles out of that initial 400 are coming from those individuals there. Oops, that pen just broke. Then don't forget our heterozygotes. We had 25 heterozygotes, and they each had 1 of those dominant alleles, so we'll just leave it right there. So to figure out the total of the dominant number of alleles, we'll take 100 plus 25, 125. So to figure out the frequency then of my dominant allele, and we had total 400 alleles in this now gene pool of my future generation. So we take 125 divided by 400. And so now the frequency of my dominant allele in my future generation is equal to 0.3125, meaning out of my population of 200 iguanas, 31.25% of them have that dominant allele. So we could either stop right there or continue on, but just right there we can compare to see my future generation versus my original generation to see if that frequency of that dominant allele, is it the same or is it different. So right now in my future generation, that's the frequency of my dominant allele, 0.3125. the frequency of my original population of my dominant allele was 0.8. So are those numbers the same or are those numbers different?
Different.
Definitely different. So we have less individuals having that dominant allele, more individuals now having that recessive allele. So to answer my initial question, is the trait of non-webbing, is it becoming more common or now less common in the population?
Less common.
Less common in the population. So therefore, is my population evolving? Are these frequencies changing?
Yes.
So is it in Hardy-Weinberg equilibrium?
No.
No, because those values are now different in my later generation. It is not in Hardy-Weinberg equilibrium. We can stop right there. We don't have to continue on and calculate Q. All right, guys. Hopefully that helped answer some of those questions, and I'm going to go ahead and put all these little clips together and make one video for you guys. Bye. Miss you. Let me know if you have any questions. You have some more practice tomorrow, so use this to help you out.